Hello physics class, this is Armand Ramazani and I'm going to be teaching problem number 13 from chapter 2 of Physics C. So the problem reads, a particle moves along the x-axis according to the equation below. X is in meters and t, time, is in seconds. X is equal to 2 plus 3t minus t squared. The problem asks us to find the position, the velocity, and the acceleration when the time is equal to 3 seconds. So our first plan of action is to simplify this equation, and then let's graph it out for simplicity. So here below, I've written out the steps to make it easier for us to graph. So here I just simplified the numbers from 2.00 to 2 and etc. and 3.00 to 3. And then I took out the negatives, and then I put it into better form for graphing a quadratic equation. Then I saw that since we're trying to go up to time is equal to 3 seconds, but in order to better understand the equation, I was going to see at when time is equal to 0, when time is equal to 1, when time is equal to 2, and when time is equal to 3, what the graph of the position looks like. So at time is equal to 0, it is at 2 meters, so 0, 2. When time is equal to 1 second, it's at 4 meters. When time is equal to 2 seconds, again, it's at 4 meters. And when time is equal to 3 seconds, again, it's at 2 meters. So we clearly see that this is a parabolic equation. We can just draw the curve in. Okay, great. So now that we see how it looks like and how its slope is positive here up until in between 1 and 2, so at 1.5, it has a tangent of 0, which means that the velocity is equal to 0 at 1.5 seconds. The slope is positive here, and it's negative there. Okay. So let's move on to the actual problem. So here again, the instructions are find A, the position at t is equal to 3. So that's easy. You just take x is equal to 2 plus 3t minus t squared. So there we just substitute 3 for t. So x of 3, because x is a function of t, time, is equal to 2 plus 3 minus 3 squared, which equals 2 meters. So there we found the position. X at 3 seconds is 2 meters. Next, let's find the velocity, which involves the use of calculus. Okay. So there's letter B. So let's take the derivative of each of these parts, and this is a polynomial. So for the derivative of a polynomial, what you do is, if it's a constant, the slope is 0. The derivative or the slope is 0. For something that has a variable, such as t to the first power, then what you do is you take, or any power, you take whatever the power is, multiply times the coefficient, and then you take 1 minus that power. So in this case, we know that constants have a slope or derivative of 0. So I'm gonna write the equation here just for ease for subpoint B. Okay, so v for velocity, because that's a derivative of the position x. 2 is going to become 0 because there's no slope, because it's a flat line, it's a constant. So remember, the 3t is to the first power, so you're going to multiply 3 times 1, and then you do the power minus 1 for each derivative, which becomes the 0 power. So that becomes 1. So I'm going to write 1 again, just to signify that t to the 0 is equal to 1. Then for here, remember, we take whatever the power is and make it the coefficient, or multiply it times the coefficient, which is negative 1. So it's negative 1 times 2, then 2 minus 1 is 1. It's going to be to t. So the velocity is 3 minus 2t. So the velocity at 3 seconds is equal to 3 minus 2 times 3, negative 6. And coming back to our graph, we see by just doing a tangent and just by looking, we see that this is a pretty negative downward slope at t equals 3 seconds. So you can see like the tangent there looks about to be negative 6 according to this scale. Okay, now we're going to be going on to the acceleration. And acceleration is the derivative of the velocity. So again, we're going to be taking the derivative of part B. Meters per second. Okay. So for C, we're going to be trying to find the acceleration. So let's just take the velocity again. V equals 3 minus 2t. So acceleration is the derivative of velocity, and the derivative of a constant is 0. And then t is to the first power, so you multiply 2 times 1. And then you subtract whatever that power is by 1, so it will become t to the 0, which is 1. So the acceleration is at a constant negative 2 meters per second squared. So since we're still trying to find the acceleration at 3 seconds, a of 3 is equal to negative 2 meters per second squared. Okay, thank you for watching, and please ask me any questions that you have on problem number 13 or derivatives in general. Thank you.